Hi everyone, welcome back to the class. Today, lesson number 9 of electrostatic potential and capacitance. In the previous class, we discussed parallel plate capacitor, equation for the capacitance of a parallel plate capacitor. Today, we will discuss series and parallel combination of capacitors. In 10th standard, we learned how resistors are connected in parallel and series. Now we will do capacitors are connected, series and parallel. We will discuss their combination. When capacitors are connected in series, series combination, end-to-end connection, or we can say hand-to-hand connection. In series connection, there is only one path for the flow of charge. Okay, so charge through all the capacitors, charge on all the capacitors will be same in series combination. But potential difference will be different if the capacitors are having different capacitances. Capacitors, series combination of capacitors. Series combination. Series combination of capacitors. See, 3 capacitors I am taking. This is C1, C2, C3. These are connected in series. See, there is only one path. Okay, so suppose charge on this capacitor is plus, this plate minus, here will be plus. So same charge appears across all the capacitors. This is series connection. This is connected to a potential difference V. Here, potential will be divided. Potential across capacitance C1 will be V1, C2 will be V2, C3 will be V3. Total potential V is divided. So total potential will be equal to V1 plus V2 plus V3. And you know the equation for charge. What is charge equation? Q is equal to CV. So we can write V as Q by C. V1 will be Q by C1. V2 will be Q by C2. V3 is Q by C3. If C is the equivalent capacitance, what is equivalent capacitance? It is a capacitor having a single capacitance equivalent to the 3 together. That is known as equivalent capacitance. Okay, if we can replace the 3 capacitors by one single capacitor, that is known as equivalent capacitor. So we can put in this equation. If C is the equivalent capacitance, we can write V is Q by C. So we can write the equation as Q by C equals Q by C1 plus Q by C2 plus Q by C3. Charges will be cancelling. So you will get 1 by C equals 1 by C1 plus 1 by C2 plus 1 by C3. So this is the equation for the equivalent capacitance in series. So reciprocal of the equivalent capacitance is equal to sum of the reciprocals of the individual capacitors. You know, when resistors are connected in series, you got equation as R equals R1 plus R2 plus R3. In capacitors, it is 1 by C equals 1 by C1 plus 1 by C2 plus 1 by C3. So remember, when capacitors are connected in series, same charges appear across all the capacitors. Potential is divided among all the capacitors. Effective capacitance is 1 by C equals 1 by C1 plus 1 by C2 plus 1 by C3. Effective capacitance will be the smallest of the smaller than the smallest of all the individual capacitors. Now we can discuss capacitors in parallel. Here we connect all the capacitors between the same points. Across the same points, we connect all the capacitors across two common points. This is one capacitor. Here again we are connecting capacitor C2, C1, C2, C3. So these all are connected to a common potential difference, source of common potential difference. So potential difference is same, but charge will be dividing here. So total charge is Q. Here charge will be Q1 for the first capacitor, Q2 for second, Q3. So total charge will be the sum of the individual charges. Total charge Q is equal to Q1 plus Q2 plus Q3. And Q you can write as CV. C is the equivalent capacitance. So we can write CV equals C1V plus C2V plus C3V. You cancel all V. You will get C equals C1 plus C2 plus C3. So equivalent capacitance in parallel combination is the sum of the individual capacitances. So remember, when capacitors are connected in parallel, charge is divided among all the individual capacitors. Potential difference is same. Okay. Now we will do a numerical based on series and parallel combination. See, I am giving a combination of capacitors. Okay, this capacitance C1, C2, C3, C4, and this is connected to a source of potential difference at 12 volt. This circuit diagram is given. Question number 1, calculate the effective capacitance. Then calculate charge on each capacitor. Third, calculate total energy stored in the combination. Values are also given. C1 is 10 microfarad. C2 is 5 microfarad. C3 is 10 microfarad. C4 is 5 microfarad. Okay. Now you look at the diagram. You see the path, the top path. A, B, C, D. See the path A, B, C, D. There is no branching. Okay. There is one path from A to A, B, C, D. So these three capacitors are series because same charges will flow through all these three capacitors. Between C2, C3, C4, there is no division or no branching of the circuit. So these three are in series. Then first to find out series of these three, C2, C3 and C4. Then you have to replace with the one single capacitor. Find the equivalent capacitance of C2, C3, C4. Then replace it with the equivalent capacitor. Then that capacitor and 10 microfarad C1 will be in parallel. Okay. So we can determine the equivalent capacitance. So first you find out C1, C2, C3. The C2, C3, C4 in series. C2, C3, C4 are in series. So we can find out one by equivalent. I write it as 1 by C 2, 3, 4. The equivalent of capacitors 2, 3 and 4. What is the equation? Series we learned now. 1 by C2 plus 1 by C3 plus 1 by C4. Put the values 1 by 5 plus 1 by 10 plus 1 by 5. This is 2 by 5 plus 1 by 10. 1 by C2, 3, 4 is 4 by 4 plus 1 by 10. So 5 by 10. So what is C2, 3, 4? 10 by 5 is equal to 2 microfarad. So we found out the effective of C2, 3, 4. Now we can redraw the diagram. This is C1. And instead of C2, 3, 4, you draw it like this, C2, 3, 4. Now C1, C2, 3 are in parallel because charge division occurs here. So now we can find out the equivalent capacitance. C2, 3, 4 and C1 are parallel. So what is 1 by C equivalent? We can write C 1, 2, 3, 4 total capacitance. Parallel, you know, capacitance add up. You can write C equivalent. C2, 3, 4 plus C1. What is C2, 3, 4? 2 microfarad plus C1. What is C1? C1 value was given. C1 is 10 microfarad. So total is 12 microfarad. So this is equivalent capacitance. Now what is the second question? Read the question. Calculate the charge on each capacitor. Charge on each capacitor. Now C234, you know, for C234, capacitance C234 are in series, so they will have same charge. So we can write Q234. What is the charge? CV. Question is CV. C234 into V. Potential across C234 is 12 volt. You found out C234 as 2 microfarad. 2 into 10 raised to minus 6 into 12. So what you are getting? 24 into 10 raised to minus 6 coulomb, or 24 microcoulomb. Okay. Then you can find out the charge on the C1. The formula is Q is C1V1. So this Q234 will be same across Q2. So here we can write Q2 equals Q3 equals Q4. Now we can find out charge on C1, Q1. What is the equation? C1 into V. C1 is given as 10 microfarad. Okay. Into V is 12. So what will be the answer? 120 into 10 raised to minus 6. 120 microcoulomb. Okay. Now, third part of the question. What was third part of the question? Energy stored in the system. You know the equation for energy. What is the equation for energy stored? Half CV square. Okay. Half CV square. E is equal to half CV square. C is the equivalent capacitance. Half into equivalent capacitance you calculated as equivalent capacitance you calculated as 12 microfarad. 12 into 10 raised to minus 6 into V is 12 square. So this you cancel 6. So 144 into 6 into 10 raised to minus 6. You have to calculate this. (864) into 10 raised to minus 6 joules. So in this way, we can calculate equivalent capacitance and energy stored in the system. Okay, children. I will give another question. Calculate the equivalent capacitance of the combination of capacitors shown below. Okay, I'm giving the diagram. Four capacitors are connected in this way. I'm naming it C1, C2, C3, C4. Now, this point is A. This point A is connected to this point. Okay. Similarly, here I take a point. It is connected to this point. Okay, and naming this point A, B, C, D. Okay, so you have to find out the equivalent capacitance of this combination. Values are given. Say C1 is 10 microfarad. C1 is 10 microfarad. C2 is 5 microfarad. C3 is 10 microfarad. And C4 is 5 microfarad. Okay, you have to find out the equivalent capacitance of the combination. You need capacitance between the points A and E. Now we have to simplify the diagram. You have to identify which all capacitors are in parallel and which are all capacitors and series. Look at the diagram. You can see the point A is connected to the point C by a conducting wire. This is a conducting wire. That means A and C will be connected at the same point only. They will be at the same potential. A and C, the points A and C are at the same potential. They are the same points only because they are connected by a wire. Similarly, the points B and D are the same points, same potential. B and D will be at same potential. They are same points. They are connected by a conducting wire. Now we can redraw the diagram. Okay. I am numbering the plates also for easy purpose for your understanding. First plate, second plate, first plate, second plate, first plate, second plate. Okay, first plate, second plate. I told you point A and C are same points. So at the point A, you can see three plates are connected together. The plate 1 of first capacitor, plate 2 of first capacitor, and plate 1 of third capacitor. So these three plates are connected at the same points. So I am redrawing here point A. Okay, here first plate of C1 is there. Then at the point A, second plate of C2 is there. See, second plate also connected, first plate of C1 is connected. Second plate of C2 is connected. This is for C1. This is second plate of C2. And first plate of C3 also is connected at the point A. So this is C3. Okay, first plate. Now consider the point C. This point is A. At the point, consider the point B. Now you consider the point B. At the point B, second plate of A is connected. Okay, first plate of C2 is connected. And first plate of second plate of C3, first plate of second plate of C2 is connected there. So we can draw here. Second plate of C1 is connected. First plate of C2 is connected. And second plate of C2, C3 is connected. Okay. So these all plates are connected. These all points are B, point B. Now you can see at the point B, fourth capacitor is connected, first plate. Second plate is like this point D. So we have to draw the equivalent diagram like this. Now look at the capacitors C1, C2, C3, they are in parallel. Okay, and the capacitor C4 is in series with it. Now you can simplify. Further simplification, we can write here this capacitance C2, C1, C2, C3 parallel. So what is the total resistance? C1 is 10 microfarad, C2 is 5. So 10 plus 5, 15 plus C3 is 10. So what is this capacitance? This parallel combination, 10 plus 5, 15 plus 10, 25. Now 25 microfarad is in series with this 5 microfarad, C4. Okay. Now you can find out the equivalent capacitance. 1 by C equals 1 by 25 plus 1 by 5. Okay. So 1 by 25 plus 5 by 25. So C will be 1 by C equals 6 by 25. C will be 25 by 6 microfarad. Okay. So when you are giving a complex circuit, you simplify in this way. One more question I will give you. Find the equivalent capacitance and energy stored in the system of capacitors. Find the equivalent capacitance and energy stored in the system of capacitors shown below. So I am giving a circuit, one capacitor, another one connected like this, connected like this, connected like this, connected like this. Another capacitor is connected in this way, connected like this, and we are connecting here a 6-volt battery. Name this capacitor C1, that is 2 microfarad. This capacitor C2, 2 microfarad. This capacitor 2 microfarad. C3, middle is C4, 1 microfarad. This C5, 2 microfarad. And this is C6, 1 microfarad. C7, 2 microfarad. Okay, these are the system of capacitors. You need to find out the equivalent capacitance and energy stored. First, you look at the circuit. Identify series and parallel combination. you can see series means there should not be any branching or division of charge among them. So when you look at here, C2 and C3, there is no division of charge or no branching between these two. So these are in series. So first you simplify, you find out series combination of C2 and C3. And writing equivalent of C2 and C3, C23. What is the formula? 1 by C2 plus 1 by C3. Both are half, 1 by 2, 2 microfarad. So it will be 1. So to C23 will be 1 microfarad. So now we found out series combination of C2 and C3. Now this C2 and C3, look, we had to replace this by a single capacitor. Okay, so we can, if you want, we can draw the diagram, redraw the diagram like this. This was C1, C6, this middle was C4, it is 1 microfarad. Okay, now you found out equivalent of C2 and C3. So C2 and C3 is in parallel with the C4. So this is C23. Now you can find out parallel combination of C23 and C4. So what is C234? C23 and C4 are parallel. C23 you found as 1 microfarad. So this will be 1 plus C4 also 1. So it is 2 microfarad. Okay. Now you have to replace C23 and C4 by as a single capacitor, this one. So what will be the diagram now? Diagram is again reduces like this. Again, you can reduce the diagram. This was C6. C6. Here there is a capacitor that is C5. Okay. So this you replace. This is C234. Now the diagram is simplified like this. Now you see this C234 and C5 are in series. Now you find the equivalent of C23 and C5. That is the next one. Next step you have to do. C234 and C5 are in series. So what is the effective resistance now? You take that as 1 by C2345. That will be 1 by C234 plus 1 by C5. Okay. C234 you got as 2 microfarad. And C5 is 2 microfarad. So find the equivalent capacitance. 1 by C2345 is 1 by 2 plus 1 by 2. You get as 1. C2345 is 1 microfarad. Okay. Now you again simplify the diagram. Now we have to replace C23 this by a single capacitor. So final next step diagram is this was C1, C6, this one was C7, this is C6. Now you know C2345 you have to replace by this 1 microfarad capacitor. This is C2345, 1 microfarad. Now you can see this C6 and the C2345 are in parallel. So what is the effective capacitance? C23456. That is C2345 plus C6. That is 1 plus C6 is 1 microfarad. It is given as 1 microfarad. Let me see. One microfarad. So we can write thus 1. So 2 microfarad. Now again you simplify the diagram. You replace this by this 2 microfarad. So what will be the final circuit diagram? Simplified one. This was C6 and this you got as C6 and C2345 you got as 2 microfarad. So this is, so final diagram comes like this. This is C23456. C1, C7. See, all these capacitors are series. So what is the final equivalent capacitance? 1 by C equals 1 by, what was C1? 1 by 2 plus 1 by 2 plus C7 also 1 by 2. So 3 by 2. So equivalent capacitance of the combination C equals 2 by 3 microfarad. This combination is connected to 6-volt battery. Now we can find the energy stored. Half CV square. You know the equation for energy stored. Half into C is 2 by 3 into 10 raised to minus 6. V was 6 square. So you are getting 36 by 3 into 10 raised to minus 6. 12 into 10 raised to minus 6. 2. So we calculated. So you have to simplify the diagram in this way. Okay, children. So dear children, here we end the class. Watch the video, practice yourself, share maximum. Thank you for watching. Goodbye. We will meet you in the next class.